Let's take a quick case study of a patient that is new to you. This is a 43-year-old Hispanic woman in to see you for a checkup. You have given her a new diagnosis of diabetes with an A1C of 7.4%. She is currently on no medications and is asymptomatic. She has no comorbidities. With a new diagnosis for a patient, my thought process tends to look a little something like this. We use our training and our experience to formulate a plan based on the patient's variables, including their age, comorbidities, and perhaps their med list. But it's that little sliver of first line therapy that is often missed or isn't expounded upon in some of these treatment algorithms. The PhytoRx program is a collaborative community health program that aims to improve nutrition education for healthcare providers, but also empower community members to make healthier choices by utilizing the resources that they already have available in their community. So this is going to improve your knowledge of nutrition and give you some insight on how to interweave nutrition science into the patient's therapeutic plan of care. Because there is so much conflicting information about nutrition out there, the PhytoRx program uses the evidence-based Med Instead of Meds program to help providers learn how to communicate with patients about healthy diets. In addition, PhytoRx translates up-to-date phytochemical information as it relates to human health. The PhytoRx program adds added structure to that first-line treatment in the algorithm. So phyto just indicates that these are the phytochemicals in fruits and vegetables that actually benefit health, and the RX indicates that you're going to prescribe it for a specific diagnosis. The healthcare provider training that you are taking is just one piece of the puzzle. Once you write that prescription for produce, the patient will take the prescription to have it filled at a food pharmacy, which can be a food bank, a grocery store, or a farmer's market. They will also need added education on how to prep, cook, and store these healthy foods. Added resources can help reconnect the food the patient is eating back to their health. Let's take a look inside the world of phytochemicals and human health. So what are phytochemicals exactly? And what do they do for plants? And what do they do for our own health? Take a look at these two short videos to find out some more information.
You've probably heard that leaves of deciduous trees change color in autumn because they lose their green chlorophyll molecules, allowing the underlying yellow and orange pigments to shine through. However, this doesn't explain why the leaves change color in the first place. Deciduous trees drop their leaves each year to avoid the high cost of winterizing them, but this seasonal shedding would be too wasteful to be worth doing if the trees lost all the valuable nutrients they laboriously extracted from the soil to build their leaves earlier in the year. So each fall, deciduous trees recycle their leaves before dropping them. That means taking apart cells and photosynthetic apparatus from the inside out in order to recoup their nitrogen and phosphorus and store it in twigs and branches until next spring. This is actually really tricky because as the disassembly starts, the chlorophyll molecules that absorb sunlight for photosynthesis are still absorbing the sun's energy. But with no photosynthesis happening, they end up passing the unused energy along to oxygen molecules, which become dangerously reactive when energized. These molecules wreak havoc, damaging the parts of the leaf that are in the process of recovering and transporting nutrients back to the rest of the tree. To keep this destruction to a minimum, leaves break down their chlorophyll into less dangerous molecules that are typically transparent, though sometimes yellow. Either way, with the bright green molecules gone, yellow and orange pigments that were there all along helping with photosynthesis are no longer overshadowed, and ta-da! Yellow and orange leaves. Some trees take an extra autumnal precaution against chlorophyll-induced destruction. As the leaf dismantling starts, they build new special pigments to shade chlorophyll from sunlight until it can be broken down. These new pigments tend to be red or purple in color, so trees that use them have red leaves in the fall, sometimes insanely bright red. In the end, these exquisite gold and russet displays help deciduous trees recover as much as 50% of the nitrogen and phosphorus from their old leaves to help grow fresh new green ones in the spring. They are perhaps the world's prettiest recycling plants.
My name is Marianne Lila, and I'm the director of the Plants for Human Health Institute, and this entire institute is dedicated to discovering how plants produce compounds can help improve our health. And I've looked at many different kinds of plants, fruits and vegetables and herbs, but the one that I really concentrate on the most is berries. The more I get to study the berries and find the differences in what they have inside of them, the more we can discover how best to prevent many of the chronic diseases that plague our nation, but the whole world today. One piece of research that I've done recently that's very exciting to me is in cooperation with Appalachian State University, one of my partners on campus, and Dole Nutrition Institute, another partner on the campus. And here we took berries and we examined what berries do to performance in an athlete. It's not the way you normally think of berries helping athletic performance, but it does. Berries are well known to reduce oxidative stress. An athlete has a lot of oxidative stress. Berries reduce inflammation. An athlete who is running hard or cycling hard is highly inflamed. So we looked at berry consumption and what that did for an athlete. There's some combination of exercise and eating berries that gets those compounds more readily to different parts of the body to do their good work. We also found, and it was intriguing to us, that berries increased the rate of ketogenesis. This means the ability to burn fat. Interestingly, the burning fat was much higher while the athletes were exercising, but then the next day, they were still burning fat at a higher level. Wow, burning fat while you sleep? This is a great message, I think, for berries, for many people who could use this message. Because many people worry about berries. They think, oh, this is sweet. Berries are sweet, maybe it'll make me fat. No, people need to realize that, because not only will berries not make them fat, but they can actually help them to burn fat cells more. Each berry is different. Each berry has a little bit different compounds. All of them together give you the best protection. It's not just one magic bullet from the berry that does the job. It's this wonderful conglomeration of compounds, this cocktail, that when taken into the body, it's better than any pharmaceutical for some of the human health ailments, some of the things that people worry the most about, like diabetes, like obesity. You can so easily prevent or cure some of these diseases just by berry consumption in the right way. On the plate, many different colors is the best way to ensure that you're really eating the best for your health.
So, phytochemicals are those non-nutritive chemicals found in plants that can have an effect on health. We're going to focus on 3 today: anthocyanins, carotenoids, and isothiocyanates. Now, there are thousands of phytochemicals in our foods, many of which can have an effect on our health, including phytochemicals that are in pharmaceutical medications like Coumadin or warfarin. It's in that coumarins under polyphenols. We're going to focus on anthocyanins, which is under polyphenols, carotenoids, which comes under terpenoids, and glucosinolates, which turns into isothiocyanates under the organosulfurs. I want to share a few specific papers with you that I really think illustrate the power of phytochemicals. In this study, blueberries were fed to participants for 14 to 18 days before a 90-minute exercise session. And then they stopped the intake of the blueberries. And what they found was that anti-inflammatory oxolipins were elevated even after the exercise and after the stop of the blueberry ingestion. If you take a look at the graph on the left, you'll see that the blue line indicates those participants who were ingesting the blueberries about a cup a day for 2 weeks prior to the exercise, and those taking the placebo are there in orange. And you'll note that this is an anti-inflammatory level now. You'll note after the exercise session that anti-inflammatory level remained elevated. I want to share with you some really interesting studies about phytochemicals and the human body. So the review at the top left looks at a lot of recent studies that identify blueberries as a potential for treating and preventing skin disease. Although preliminary studies have concluded that blueberries do have this potential, they highlight the need for more specific research in this area. Ox inflammation, and we're looking at the bottom right now. Ox inflammation is a term that was coined in 2018 to indicate that inflammation cannot happen without oxidative stress, and oxidative stress cannot exist without inflammation. Although not every aspect of Alzheimer's is understood, the science shows us that this ox inflammation system can be triggered by the peripheral or central nervous system and can cause cytokines to cross the blood brain barrier and can cause exacerbated symptoms. Blueberries can protect against this ox inflammation to help ease behavioral symptoms. It is well reported that elevated levels of trimethylamine N oxide, or TMAO, can lead to increased risk of atherosclerosis. The diagram at the right shows that dietary choline can be converted into TMAO in the liver. Choline typically comes from eggs and some other animal products, and sometimes in plants. What the authors have found is that some phytochemicals, mostly polyphenols and glucosinolates, can have an impact on the amount of TMAO. Interestingly, this happens by way of affecting the gut microbiome and interferes with the body's ability to make TMAO. Let's focus in on a couple of more specific phytochemicals. The first is anthocyanins. These are plant chemicals that form a pigment that is present in dark red, blue, and purple fruits and vegetables. They have a huge anti-inflammatory property, and they're specifically good for cardiovascular disease and diabetes. Some examples of anthocyanins are cyanidin, pitunidin, malvidin, delphinidin. And you'll find these in fruits and vegetables shown here: raspberries, purple cabbage, black beans, red onions. You're seeing that really dark purple, blue, and red pigment. If you're thinking that some of these phytochemical words are long and hard for patients to say and they may never catch on, I like to offer you this advertisement that I found at a festival, a lavender festival, and they were advertising their elderberries and elderberry tea. And right there in the second column, you see that they're advertising the anthocyanins. So it is becoming more mainstream. So, what can anthocyanins do for us chemically? Well, they can prevent and treat diabetes by increasing GLP-1 secretion, much like Ozempic, Trulicity, or Rybelsus, and they also inhibit DPP-4, much like Januvia and Tradjenta. In general, they decrease inflammation after a high-fat meal as well. The next phytochemical is carotenoids. These are the plant chemicals that have the pigment in yellow, orange, and some red fruits and vegetables. They absorb blue light, so thinking about technological devices and the sun's blue light rays that can damage the retina of the eye. Carotenoids are also anti-inflammatory, and they're specifically good for both skin and eye diseases. Some of the names of the specific carotenoids may be a little more familiar to you: alpha carotene, beta carotene, lutein, lycopene, zeaxanthin. Here's some of the foods that they're found in. So sweet potatoes, carrots, pumpkin, mangoes, those are very easy to see. Even the red peppers, those red, yellow, and orange. But also dark leafy greens have a lot of carotenoids. And we see this because if you remember back in that video that I showed you a little bit ago, that the chlorophyll in the dark leafy greens covers up that red, orange, and yellow coloring. Our next phytochemical category is carotenoids. These are plant chemicals that come from the pigment that's in yellow, orange, and sometimes red fruits and vegetables. Carotenoids absorb blue light, so you're thinking technological devices and even the sun's rays that can damage the retina of the eye. Carotenoids are anti-inflammatory, and they're specifically good for skin and eye diseases. With respect to skin health, carotenoids can affect internal and external defenses to reactive oxygen species. So that means we can put carotenoids both on top of our skin to help protect us from reactive oxygen species, and we can ingest carotenoids to help. Environmental pollutants and stressors can change the amount of carotenoids we need. And this makes sense because carotenoids are antioxidants. And as the reactive oxygen species hit them, they protect us, but then they are used up. So if we have increased stressors like smoking, or if we live in a big city, we're using up those carotenoids that we have stored in our bodies. We need to ingest more of them than someone who doesn't have those same stressors. The quality and processing of the carotenoids will determine bioavailability. So that means that the quality, so how it was grown, if it had good soil, those types of things, but processing also will determine bioavailability, meaning that lots of carotenoids that are in a tight matrix, like with carrots, pumpkins, any of those harder fruits and vegetables, and processing will need to be done in order to release them from that matrix so that we can better use them in our body. So that means blending, cooking, juicing will all help make the carotenoids themselves more bioavailable. Carotenoids are also great for eye health. Lutein and zeaxanthin are the only carotenoids found in the macula, and we do not make these carotenoids. They can only be found in what we eat. Supplementation with lutein has been shown to increase thickness of the macula as well. Effects of diabetic retinopathy and age-related macular degeneration are decreased with carotenoid intake. Isothiocyanates are chemicals that form as byproducts of the phytochemical glucosinolates found in cruciferous vegetables. This is more of a taste profile rather than a color indication that the phytochemical is present. Isothiocyanates often have a bitter taste, so that's how you'll know that you're eating them. Isothiocyanates have antibiotic properties, anti-inflammatory properties, and even anti-cancer properties. Here are some examples of isothiocyanates. There's allyl, benzyl, methyl, and phenylethyl isothiocyanates. And here are some of the foods where they can be found: broccoli, cauliflower, bok choy, kale. You'll see they all have that bitter sort of taste that you know from cruciferous vegetables. Isothiocyanates are particularly good at cancer fighting. AITA is great for bladder cancer. PEITC shows that it inhibits carcinogen formation in breast cancer. DATS, which is a byproduct of AITA found in onions and garlic, can disrupt the cancer cycle, leading to long-term prevention of recurrence. This is the final slide on the specific phytochemicals, and we're going to move into a more general way to talk to your patients about nutrition and diet.